Okay, so this is problem 20 of chapter 19 of Giancoli 6th edition. So this problem looks more complicated than it really is. Now we want to find what is the equivalent resistance for this circuit. So it has this funny geometry, but it's not that bad. We have to go piece by piece. And what we know is that all the resistances are the same. Okay, so the first thing that I'm going to do is I'm going to look for one piece that I can simplify already. Well, look at this one. This one, the two are in series, so I know that this whole resistance here is just, so I'll call this first one, I'll call it the 1, 2. Now, if this resistance is the resistance 1 and this resistance is the resistance 2, so this R1, 2 is 2R because both resistances are the same and you can find the number. Okay, now what do we have? I have now this one in red is in parallel with this one in black here. Let me put it blue. Okay, so it's in parallel with this one. You see here at this point A and B is the junction for these two guys. Okay, so what do we have? Let me try to make it more clearly. A and B and A and B. So that's that piece that I said. This is the 2R that we just found and this is R. So it's in parallel. It's in parallel, so I'm going to find the equivalent resistance for these two guys. What is it going to be? Well, the equivalent resistance here will be 1 over R plus 1 over 2R. We go through that. Now we have here 2R and on top we have 3. So we found that this equivalent resistance is 2R plus 3. Okay, so I got rid now of this whole piece. Okay, so let me try to make my drawing now. What I have is between A and B, I have now a single resistance between A and B, which is that 2R over 3. And what do we have? What else do I have? I have this resistance here, I have this other resistance here. Okay, and then I continue down there with my battery and another resistance. Okay, so here I have point A and B, and here I have point C. So A, B, C is series. So I can get these guys here, A, B, C, to get my new resistance. So this new resistance here for this series piece is going to be 2R over 3 plus R. So this will give us 2 plus 3, 5R. Okay. What else do we have? Now I simplified it, so I'm going to make my drawing. Instead of A, B, C, I have a single piece now, which goes from A to C. From A to C, I have this new resistance, which is 5R over 3. And also from A to C, I have another resistance there, R. Okay? And then I continue with my battery and that other resistance. Now A and C here have two resistances in parallel. Alright, so I'm going to simplify now these guys. Now they are both between A and C. So what is going to be the equivalent resistance here? Well, 1 over the equivalent resistance is 3 over 5R plus 1 over R, and from here I get 5R, 3 plus 5, and so the equivalent resistance there in red, for that piece in red, is 5R over 8. Okay, almost there. So let me show now how my circuit looks like. Well, I have for that piece between A and C, I have now just one single equivalent resistance, which is that 5R over 8. Okay, so that's my point A to C. And then from C down to the battery, I have another resistance and the battery. Okay, so now things became very simple. I have now just two resistances in parallel, so I can add the two, and I have 5R over 8 plus R, and so I have 13R. This is our equivalent resistance. Now you put the value for R there and you get a number.